Time for trigonometry. So, there's a new pacing guide. This won't matter for today, but for the future, you will want your calculator in degrees. Just press the mode button, and where you see radians, degrees, make sure degrees is highlighted. I'll often use Greek letters for angles. This is theta, alpha, and beta. They're just like x or y, they're just variables. We'll be talking a lot about the quadrants, so make sure you know where they are. Where x and y are both positive, that's quadrant 1. Where x is negative and y is positive, quadrant 2, and so forth. Counterclockwise. If an angle measure is counterclockwise, it's considered to be a positive angle, that is into quadrant 1 and onward is a positive angle. If it's going clockwise, so backwards through the quadrants, that's a negative angle. Degrees are in base 10, but minutes and seconds are in base 60. So if you need to convert one way or another, minutes over 60 will give you fractions of a degree. Seconds over 60 squared will also be fractions of a degree. So to solve, if you have a problem where you need to convert from decimals to degrees, or decimals to degrees, minutes, seconds, or from degrees, minutes, seconds to degrees, you set up a correspondence. So here, 329, that part is just fine. You don't need to do anything to that. That's 329 degrees. But for the 0.125, 29 degrees. But for the 0.125, it's 125 thousandths. But how many minutes is that? So each minute is 1/60th of a second. To find out how many minutes there are, we set up this proportion, solve for m, and you find that this is 7.5 minutes. So 7.5 minutes. Now this 7, the whole part of this, that's fine. We'll go ahead and put that in. It's 7 minutes. But 0.5 minutes, well, we can turn that into seconds. 0.5 minutes is how many 60ths of a minute, because each second is 1/60th of a minute. You solve that, and you find that 0.5 of a minute is 30 seconds. So 329.125 degrees is the same as 329 degrees, 7 minutes, and 30 seconds. Going back the other way, if you have minutes and seconds, and you want decimals, you put the minutes over 60, you put the seconds over 60 squared, or 3600, and then you plug that into the calculator. In this case, it comes out to be 0.2019444444. We're going to round to 0.202. Sorry about that. And again, the whole number part stays the same. That's just 35. And then our degrees and minutes are going to turn into fractions of a degree. So 35.202 seconds. And by seconds, I, of course, actually meant degrees. So the next part of this is to give the angle measure represented by 9.5 rotation clockwise, 6.75 rotations counterclockwise. This is extremely easy. Remember that if you're going clockwise, we're talking within the coordinate plane. Clockwise is going to be negative. Counterclockwise will be positive. So 9.5 rotations clockwise is 9.5 times negative, and one full rotation is 360 degrees, so it's 9.5 times negative 360 degrees, or negative 3,420 degrees. If we're going counterclockwise, it's 6.75 times positive 360 degrees, or 2,430 degrees, as you'll see in my notes. Next section of the notes, coterminal angles. Coterminal means ending in the same place, or ending together. So if we're envisioning our angles as taking place as occurring in the coordinate plane, but also sort of in a circle. So if you have an angle, let's call this, maybe this is 20 degrees. If you add 360 degrees to that, if you go 380 degrees, you end up in the same place. So we call 20 degrees and 380 degrees coterminal. They end in the same place. So if you're asked for coterminal angles, an angle with degree measure alpha is coterminal with all angles of the form alpha plus 360k, where k is an integer. This means starting with your original degree measure, every time you add a full multiple of 360 or subtract a full multiple of 360, you're back in the same place. You're coterminal. So to find all angles coterminal with your given angle, all you do is you say 86 plus 360 k degrees. I always have trouble with the degree sign, so let's just draw it in this time. All right, 86 plus 360k degrees, that's all angles. This is just a formula for all of them. If we're asked for an example of one positive angle, we just need to add 360 degrees, and we get 600, oops, looking at the wrong piece of paper, sorry. We get 446 degrees simply by adding 360 degrees. That's not the only correct answer. You could also have 446 plus 360 again, so that would be 1006. That would also be coterminal. To get a negative angle coterminal with 86 degrees, you would subtract 360 degrees, and you would get negative 274 degrees, which is just 86 minus 360. That's it. So 446 degrees, 86 degrees, and 274 degrees all end in the same place on a circle. And all angles that are 86 plus or minus some multiple of 360 end in the same place on the circle. So for 294 degrees, you do the same thing. All coterminal angles would be of the form 294 plus 360k degrees. A positive coterminal angle would be, for instance, where'd you go? 654 degrees, and a negative would be negative 66 degrees. So that's all it means. All three of these angles end at the same place, and any angle that is a full multiple of 360 degrees away from 294 will also end in the same place. If each angle is in standard position, determine a coterminal angle between 0 and 360 degrees and state the quadrant. Here's what standard position means. Remember that we're picturing these in the coordinate plane, and it is considered to be in standard position if its initial side is along the positive x-axis, excuse me. So any angle measure that's said to be in a standard position will be degrees away from that into quadrant 1, quadrant 2, quadrant 3, quadrant 4. So you're measuring from there. Determine a coterminal angle between 0 and 360 just means find an angle that would end in the same place on a circle, but which is between 0 and 360 because it's easier for us to work with those. So all you need to do is add or subtract 360 degrees to find a coterminal angle until you get something between 0 and 360, and then give the quadrant. So for 595 degrees, we need to subtract 360, and we end up with 235 degrees. And to figure out what quadrant it's in, here's 0 degrees, 90 degrees, 180, 270, and then, if you like, back to the beginning again, which is 360 degrees. So 235 degrees is between 180 and 270, so this is in quadrant 3. Negative 777 degrees. I have no idea what quadrant that's in, but I can find a coterminal angle and then find out. So I would need to add 360. That's not enough because I still get a negative. So I add 360 again, still get a negative. Add 360 again, still get a negative. Actually, wait, maybe this time I don't. Anyway, you add 360 degrees until you get something that is greater than 0 but less than 360, and that degree measures 303 degrees, which is in quadrant 4. Reference angles. Now, your notes and the book, they have a bunch of rules. A reference angle is defined as the acute angle formed by the terminal side of the given angle and the x-axis. If alpha, your angle, is in quadrant 1, then it is its own reference angle. In quadrant 2, you do 180 minus alpha. In quadrant 3, alpha minus 180, and in quadrant 4, 360 minus alpha. The real thing that's going on here is if you have a coordinate plane and you have an angle that's here, let's say this is 30 degrees. If you reflect this across the y-axis, this here would be 150 degrees if we're measuring from here, as we usually do. But these are very similar, right? If you put a point in the similar place along these, it would have the same y value. They would have opposite x values. And the sine and cosine would be related to each other. So it's very useful to be able to say what angle in quadrant 1 is similar to this one. So the way I think of it is wherever your angle is, you want to know how far in degrees, I just did that weirdly, didn't I? How far in degrees it is from the nearest x-axis. If you're in quadrant 1, you are your own number of degrees. If you're 30 degrees, you're 30 degrees from the x-axis. If you're in quadrant 2, you want to know how far you are away from 180 degrees. If you're in quadrant 3, still 180 degrees. And if you're in quadrant 4, you want to know how far away you are from 360 degrees. So, to find the measure of the reference angle for 295 degrees, that's quadrant 4, which means your closest x-axis is the positive x-axis, or 360 degrees. So how many degrees are there between 295 and 360? Well, you do 360 minus 295, and you get 65 degrees. So the reference angle for 295 degrees is 65 degrees. For negative 325, I don't know what quadrant that's in. I need to find the coterminal angle first. So I'm going to add 360 to it. That gives me 35 degrees. Sorry, so I have to check myself. Well, 35 degrees is in quadrant 1, so we don't have to do anything. That is the reference angle for negative 325. 227 is in quadrant, let's see, 227 is in quadrant 3. That means its nearest x-axis is the 180 degree mark. So we find out how far it is from 180 to 227, 47 degrees. That's your reference angle. Negative 210, first we've got to find the coterminal angle. So we add 360, we get 150. Now 150 degrees is in quadrant 2. That means the nearest x-axis is 180 degrees. How far is it from 150 to 180? 30 degrees. That's the reference angle. 120 is in quadrant 2. Nearest x-axis is 180 degrees. How far is it? 60 degrees. That's the reference angle.